especially during the morning,
During the
during the
morning.
morning, during the afternoon, and such.
You means in the hostel.
Yes, in the hostel.
Kau boleh buat lah aduan pelajar dekat asrama ada kan. Okay, so let's look at the puzzle, yeah. But anyway, if you can't follow or you suddenly left the Google Meet, you can always watch back the recording, yeah, whether we're up in the YouTube the latest by evening. Okay, so in the app puzzle, if you finish watching the video, the whole video, actually it's only touched that's the second part where we will madam discuss about the effect of temperature, effect of catalyst, and also have a process. Okay, so in the effects of temperature, you need to understand and you need to be able to follow that guidelines, the 5 steps. So if you look at back at your notes over here, effect of temperature, you get step 1, determine the type of reaction. Okay, and then step 2, then only you will see what is the disturbance event. Is it in the question is mentioned temperature is increasing or decreasing? Then step 3, step 4, step 5 is the consequence lah. Okay, so the first step is very important. Okay, it's very important. And then in the video over here, madam asked about what if a temperature or the system is cooled to a lower temperature. It's the same meaning as the temperature decreases. Okay, the word cool down, cool to a lower temperature. It means temperature decreases. So that one is follow which step in your effect of temperature? That one is for which steps? Step 2, isn't it? So for this step 2, you need to, it is fixed already. Temperature increases, it favors endothermic reaction. Okay, temperature increases, that is the disturbance. We want to try to lower down. Therefore, the extra heat is being absorbed in the reaction. Therefore, endothermic. But if you got temperature decreases, okay, we want to raise up the temperature. Therefore, the reaction will react to give up the heat so that the temperature will increase. So both of this sentence, dua-dua ayat ini awak kena hafal. Okay, so temperature decreases favor exothermic reaction. So for this one is exothermic. So for those who select the wrong answer, please correct your understanding, yeah. Then for the second questions over here, which of the following is the effect of catalyst to an reversible reaction? Okay, reversible, that means it's the system at equilibrium. Okay, so effect of catalyst, there's only 2. Okay, increase the rate of reaction or shorten the time taken. Sebab awak cepatkan dia punya reaction kan, jadi masa dia akan jadi singkat. Okay, so if you look at this one, the first one, equilibrium shift to the side with fewer mole of gas molecule. That is under the factors of pressure or volume. So obviously this one is wrong. Okay, to produce more product, remember that catalyst, even though you add catalyst, it will not causing any shift in equilibrium. Okay, tak ada effect dekat equilibrium shift. Jadi amount product dia tak akan berubah, tak akan meningkat, tak akan jadi kurang. Okay, so produce more product also won't happen. It's not the effect of catalyst. Okay, but then shorten the time taken. Just now, Madam have already mentioned one of the effects of catalyst. Increase the rate, shorten the time. And then last one, equilibrium constant K increases. Remember, K constant will only affected by temperature. So obviously the last one also wrong. Ramai yang pilih produce more product lah. So you need to understand that adding catalyst will not causing equilibrium shift. So semua Madam sudah bagi dalam nota dah. So boleh baca balik nota ya. Okay. And then last one, for this one a lot of you did it wrong. So we want to see why. Which of the following suggestions will not increase the yield of NH3 in Haber process? Okay, so lower the temperature to 500 degrees Celsius, add Fe catalyst, remove NH3, increase pressure, and so on. So let's look at the notes that we have got. You have got over there. Okay, so kita ada concentration. So tadi dekat puzzle ini remove NH3. Jadi kita kurangkan concentration NH3. So if you remove NH3, so here it is it. A different highlighter ya. Remove NH3. That means you remove the concentration. So jadi equilibrium dia akan shift kepada right hand side. Okay, you shift to the right to produce more NH3. So removing NH3 is actually to help to increase the yield. Okay, so dalam awak punya app puzzle, dia dapat increasekan awak punya production NH3. Okay, and then after that, lower the temperature to 500 degrees Celsius. Have a process. Okay, siapa yang tak faham dekat sini effect of temperature? Ada tak yang kurang faham? Anyone? Semua faham, tapi ramai yang salah. Senyap Tak ada soalan.
No further questions, madam.
No questions, that's fine. Alright, so Haber process, remember temperature, because the Haber process productions of NH3 ammonia, it is exothermic. So dekat sini, bila awak sudah nampak delta H dia negative value kan, tulis terus dekat atas sini exo. So kita tahu exothermic is favor in low temperature or high temperature. When temperature decreasing or increasing? Decrease temperature, right? Or is the same meaning as lower temperature. Okay, so if the factors of temperature, we need to lower down the temperature. Tapi awak kena ingat, bila kita turunkan temperature, dia tak boleh rendah sangat. Sebab bila awak turunkan temperature, dia akan jejaskan awak punya rate of reaction. Okay, so we over here later have already put the notes for you. The low temperature will reduce the rate. Therefore, we cannot reduce the temperature too much. Dia tak boleh sampai rendah sangat. Dalam industri, okay, 400 to 500 is considered average. Dia bukan tinggi walaupun bagi kita dia tinggi kan. Okay, but it is not that high. It's an optimal or a moderate temperature in the industry. Okay, so madam want you to jot down as well. There's a correction because some of the reference will give you 450 to 500. Okay, but I want you to correct for this one. Kita ikut lectures notes. Okay, lectures notes give you 400 to 500 degrees Celsius. It's still within that range, part of that range. Some of the reference it gave you 450 to 550. Okay, some of the reference give you 400 to 500. So we keep the same as the lectures notes. Okay, tolong catatkan ya. So kita turunkan temperature tapi hadkan dia sampai 400. Okay, so lower down the temperature will increase the yield of production because low temperature it favors exothermic reaction. Okay. So lower the temperature will increase the yield of NH3. Okay, increase the pressure to 900 atm. So pressure, one of the factors over here, increase the pressure. So when your pressure is within 500 to 1000 atm, for this part, 500 to 1000, that's okay. So increase the pressure, we shift the equilibriums to the side with fewer moles of gas. Therefore, you're going to produce more NH3. Semua sudah ada dekat sini dah. Okay. So the last one also will increase the yield of NH3. Yield adalah production, yeah, you remember that. But the one that will not affect the yield of NH3, okay, is by adding the catalyst. Okay, remember that adding catalyst will only increase the rate, okay, or shorten the time. It will not cause any effect on the concentrations of the product. So until this part, is there any questions?
No, madam.
Alright, so for question number 1 in your exercises, using the Lee-Chatelier principle, explain the shift in equilibrium position if any of the reactions if concentration of hydrogen gas is decreased. So I just want to know left, right, or remain constant. Explanation later, madam will give you the answer to check. Again, the answer will be uploaded into the Google Drive. So untuk satu A, awak punya jawapan to the left, to the right, or remain constant. So, is there anyone in the yes. Yes, can you hear me?
Hello? Hello?
Suara madam tak jelas.
Ah, tak jelas, madam. Sorry, madam. Saya punya internet pun slow juga, madam.
A bit noisy.
Yes, the background is noisy indeed.
A bit noisy.
Yes, unfortunately. And the internet connection is not good this morning too.
Sekejap ya, madam adjust balik. Okay. Maaf sebab madam ada kat office memang bising sikit lah. Macam ni jelas tak?
Jelas,
Jelas, jelas, madam.
Betul ya. If suddenly you all didn't hear madam say anything, you need to let madam know. Otherwise, madam akan continue je without stopping. Then you'll losing some information. So how about like this? Is it okay?
Better, madam.
Okay, thank you very much. Okay, so we continue over here. Just let madam know whether it's right, left, or remain constant, all right? Good. Can you see my screen or not? The one with my pictures on it.
Picture, madam?
My camera.
Yes, madam.
Yes.
Yes,
Can
madam.
I? So you know that I'm here, okay? Right. So for 1A, concentration hydrogen gas decrease. So equilibrium shift to the
Right.
Right.
right. Thank you. The temperature is lower. The equilibrium shift to the
Left.
left. Okay, why left? Our temperature is a little bit complicated. This one is a positive. That means your forward reaction is endo. Reverse reaction is exo. Okay. Temperature is lower favor exo. So awak ikut saja apa yang awak tulis kat bawah sini. So exothermic means reaction shift to the left. Therefore, equilibrium shift to the left. Okay, dia memang kena ikut step ya. Okay, how about C? Left, right remains?
Remains.
Remains
Thank
unchanged.
you. Remains unchanged. How about D? C2H6 is removed.
Left.
To the left. Okay. How about for E? Volume of the container is increased. Pressure decrease.
Right.
To the right. We want to increase back the pressure, yeah? So it will shift to the side with higher mole of gas molecule. How about F? Pressure is increased.
Left.
The left, as we want to lower down the pressure. So we'll shift to the side with fewer mole of gas molecule. How about for G? Adding inert gas at constant pressure.
Right.
To the right. Any reason why?
Any reason? Because the partial pressure
Decrease.
decrease. Remember that constant pressure, total pressure remain constant. Then you are forcing the partial pressure to decrease as you want to add some new gas. Okay, so partial pressure decreases. In order to increase it back, you need to shift to the side with higher mole of gas molecule. Okay, therefore, for G, shifting to the right. And last one, adding in a gas at constant volume. Partial pressure remains.
Remains unchanged.
Yeah, therefore, since your partial pressure remains unchanged, therefore, the equilibrium also remains unchanged. Okay, so the further explanations you can see through your Google Drive method. We'll upload this one in a while. Okay, but more interesting is question number 3, whereby you need to explain about the color change. Okay, so for this one, please jot down now. You jot down the answer and explanation. Okay, so for this question 3, equilibrium between COH2O6 2 plus, this is a complex ion. Okay, is shown below. So is this reaction endothermic or exothermic? The forward reaction, I mean.
Endothermic.
Endo.
Endo. So it means that the reverse reaction is exothermic. So give the observation and explain color change after equilibrium has established. So selepas awak dapat equilibrium shift. So 5 milliliter of COCl 4 2- ion is added to the system. So when something is added, that means the concentration will increase. So concentrations of this one increase. Therefore, equilibrium shift to the
To the left.
Right.
to
Left.
the left. Sebab concentration dia meningkat kan. Okay, dekat sini Madam explain dulu kan. Nanti Madam bagi jawapan penuh untuk awak catat kan. Okay, so we know that equilibrium will shift to the left. Okay, when the equilibrium shift to the left, you need to look at this color. Sebab dia sudah bergerak ke kiri kan. So tengok pada color dia. So you will see from blue color, okay, it will change into pink color, or the solutions turn pink. Or a pink color solution is observed. Solutions turns pink. Sebab sekarang ni equilibrium dia bergerak ke kiri, nampaklah pink color. So that is the factors of. For A, what is the factors?
Concentration.
Concentrations. So adding or removing, it refers to concentration. And the next one we have the system is heated. The word heated means that you are increasing the temperature. Okay, so increasing temperature favor which reaction? Endo, exo?
Endo.
Endo.
So kita catat sikit dekat sini temperature increases, it favors endothermic. So you try to predict whether it's to the left or to the right.
Right.
To the right.
To the right. Kenapa right? Sebab awak sudah tahu it favors endothermic. So go back to the equation, the one that you have written down just now. Endothermic, it refer to the equilibrium shift to the right. So color apa yang akan observe? Blue or pink or purple?
Blue.
Blue.
Blue lah.
About there to the right hand side, right? So you're going to see this blue color. So blue solution is observed. Nanti Madam bagi ayat penuh, awak catat sikit dulu. Pastikan awak faham dulu lah ya. Okay. And then the last one over here, we have the system is cool. Cool, it means temperature decreases. Favor exo or endo?
Exo.
Exo. So ke kiri ke kanan?
Ke kiri.
To the left. Okay, so if you refer to the exothermic, which is towards the left hand side. So pink or purple or blue?
Pink.
Pink solution is observed. Kenapa Madam say purple? If the equilibrium is achieved, Q equals to K. So pink campur blue, it will get purple. But it is shift towards one side, then you will going to observe the pure color, pure pink, pure blue. Kalau dia equilibrium, baru kita akan nampak purple color. Okay, so I will reveal the answer here for you to see the full explanation. Okay, so question number 3, concentration increase. So to reduce the concentration, this one is the purpose of your equilibrium shift. Kita nak turunkan dia punya concentration. Okay, so equilibrium will shift to the left until Q equals to K. That is the full explanation that you need to write down. Okay, so more COH2O6 2 plus complex ion will be produced. So pink color solution will be observed. Okay, can take a screenshot over here, yeah? System is heated, temperature increase. Okay, favor endothermic. Equilibrium shift to the right. More COCl4 2 minus complex ion will be produced. So blue color will be observed. And then the last one, system is cool. That means the temperature decreases favor exothermic reaction. So the down got some more explanation. Have you done screenshot for this one?
Madam, ni ada dalam draft yang madam?
Sorry, nanti Meda akan upload dalam drive juga lah.
Okay.
Boleh? Okay, so equilibrium will shift to the left. This one is for system is cool. Okay, so more COH2O6 2 plus complex ion will be produced and pink color solutions will be observed. Okay, soalan 2 dengan soalan 4 nanti awak boleh check lah. The explanation is more or less the same. It depends on which factor you are explaining. Is it concentration, pressure, volume, or inert gas, or temperature? Kalau dapat catalyst paling senang lah, no effect. Dia cuma increase rate dengan shorten time taken only. Okay. Right, so this is the end of chapter 6. So we left with one more chapter, which is your chapter 7. Have you get ready with your notes, chapter 7?
Yes, madam.
Yes, madam.
Okay. Just want to let you know that, ataupun madam tanya macam ni dulu. Chapter 1 hingga 6, mana satu chapter yang awak rasa paling susah?
The second chapter.
Second chapters, okay. How about the rest of you? Semua susah?
Apa madam, saya tak apa dengar tadi. Madam tanya apa tadi? Sorry madam, tak dengar.
Tak, chapter apa yang awak rasa susah? Chapter 1 hingga 6.
Chemical bonding, madam.
Chemical bonding. Okay, Lewis structures, hybridizations. Okay, yes. Chapter 1, everyone okay?
Okey je kot.
Okay, good. Madam happy dengan
Perhaps a little bit of revision on chapter 1 too, I guess.
Yeah, because it's long ago, right? Okay. But Madam want to let you know, chapter 7 is so far quite complicated. Lepas tu, jangan lost track lah. Chapter 7.1, 7.2 is kind of linked together. Dia macam topik 4. Dia semua akan berkaitan. It's all related. Chapter 7.1, 7.2. Okay, so notes, Madam, give you ready. You can actually try to understand the theory first. Then the calculations, Madam will show and guide you how to do it. Because 7.1, 7.2, quite a lot of calculation and need to use ice table. Okay, when it involves ice tables, I think you will be a little bit like, don't know how to do it. You can see from your chapter 6 lah. Okay, but chapter 7, we are going to use more ice table. Okay, so let's look at the learning outcome over here. 7.1 acid and bases. Some of it you have already learned before. Define the acid and base according to Arrhenius-Bronsted-Lowry theory. Identify conjugate acid, conjugate base according to Bronsted-Lowry theory. Relate pH, POH to ionic product of water, KW. Before this, we learned about Kc, Kp. Now you have Kw. And define strong acid and base, weak acid and base, pH, POH, pKw. Calculate pH value for strong acid and base. Okay, so this is what we want to cover for today. Okay, A, B, C, D, E. So the rest of it we will come back in the following lesson. So as the beginning of chapter 7, we want to go through some of the definition, of course, and then the example of your acid base. Okay, so acid and base, it can differentiate into 3 explanation. Okay, ada 3 explanation. So over here, Madam will write the overview for you. Acid and base, 3 definition. First of all, we have Arrhenius. Okay, the second one, we have Bronsted-Lowry. Okay, and then the third definitions, we have Lewis acid, Lewis base. So you have to know which definitions belongs to which scientist. Nama-nama semua ini adalah scientist punya nama. Arrhenius, Bronsted, Lewis. Lewis ini kena careful sebab kita pernah belajar Lewis structure. But this one is Lewis acid or Lewis base. Okay, so we look at the easiest one, Arrhenius. So Arrhenius over here, it refers to any substance that has hydrogen in its formula, and it can dissociate in water to form the proton or H plus ion or H3O plus the hydronium ion. Okay, hydrogen ion or hydronium ion. Boleh catat dia punya nama. Okay, so this one is hydrogen ion, or sometimes we mention as proton with H plus. H3O plus, this one is hydronium ion. Okay, so if you look at the example equation, HCl, when it dissociates into water, you will form H plus aqueous and then Cl minus aqueous. But HCl, when you react with water, you dissolve in water, you're producing H3O plus or Cl minus. H plus and H3O plus is the same thing. Cuma dia ada water ke tak ada water lah, sama saja. So you can either use the equation like this. With water, then you'll get H plus. Without water, you'll get H plus. With water, you will get H3O positive. Okay, H3O plus lah. And then for Arrhenius base, Arrhenius base is any substance with OH and dissociate in water to form the hydroxide ion. Nama tolong catatkan. Tapi dalam explanation boleh guna symbol OH minus, H3O plus, H plus. So this one is your hydroxide ion. Okay, but when you have the Arrhenius base, it dissolves into water, you will get NH plus, OH minus. So yang ini usual kan, dia dissociate untuk dapatkan dia punya ion. So next definition, acid base according to Bronsted-Lowry. The definition is kind of similar, yeah? It's kind of similar. Bronsted-Lowry acid explained refer to any substance that can donate a proton. Okay, you have to look at the keywords, donate a proton. So again, proton refers to the hydrogen ion H plus. Okay, whereas for your Bronsted-Lowry base is the substance that can accept a proton. So base akan accept H plus, acid akan donate H plus. Dia punya definition sudah tak sama dengan Arrhenius kan? So you need to refer this one as well. Okay, so when you can recognize Bronsted-Lowry acid and Bronsted-Lowry base, it can actually link to its conjugate acid-base pair. Maksudnya dia mesti ada partner. Bronsted-Lowry acid, dia ada dia punya partner. Base pun ada dia punya partner. So when we say partner, it link like this. Okay, so bronzed-rollic acid dia akan hasilkan conjugate base sebagai dia punya partner. So the definitions of conjugate base, a substance that remains after an acid donate the H plus. I will show you an example in a second. You just take note on the definition first. Okay, so a substance that remains after acid donate H plus. The weaker the acid, the stronger is the conjugate base. Ini adalah pasangan acid, okay, dengan dia punya pasangan conjugate base. Okay, so this is considered one pair, the reactant, the product. Okay, and then the bronzed-rollic base, the partner or the product is conjugate acid. So a conjugate acid is a substance that remains or produced, okay, after a base accepting a H plus. So base boleh accept proton kan, selepas dia accept proton, dia akan hasilkan conjugate acid. So dia adalah satu pasangan. So the weaker the base, the stronger is the conjugate acid. So base, dia punya dia punya reactant akan hasilkan conjugate acid as the product. Conjugate acid as the product. Okay, so definition we hold on first. I'll show you the example to get a clearer understanding about the definition bronzed-rollic. Okay, so look at the first questions over here. Nampak kan soalan pertama?
Nampak.
Okay, so question number 1, we have CH3COOH. Whenever you see COOH, you know it is carboxylic acid. Pernah belajar kan carboxylic acid COOH. So we can label this one as an acid. So you know that in a reaction ataupun in a neutralization reaction, we normally will have acid react with base. Okay, acid react with base. Acid cannot react. Base and base cannot react. So it must combine with two opposite properties. So water, in this case, it behaves as a base. Okay, kenapa kita cakap dia adalah acid? Refer to the definition just now. An acid can donate a proton. So kita tengok pada CH3COOH. So this proton can be donated, right? Acid donate proton. So after it donate the H plus, okay, it becomes CH3COO minus. So the substance remains after an acid donate the proton is called conjugate base. So nampak tak dia punya pasangan dekat sini? Acid, after you remove H plus, it become conjugate base. So the further explanation Madam give you over here. Because it donates a H plus to form its conjugate base, CH3COO minus. Whereas in this case, H2O behave as a base as it can accept a proton. So bila H2O dia accept proton, okay, it become H3O plus. Remember, hydrogen has a positive charge. So H2O plus H plus become H3O plus. So a base, after accepting a proton, producing a conjugate acid. So dia adalah satu pasangan. Do you get what I mean over here? Is it clear?
Yes, madam.
Clear.
Okay. So tell me about for questions for 1B. So this one is our A, this one is our B. HClO, is it an acid or a base? Bronzed-rollic acid or bronzed-rollic base? Tapi awak kena catat acid base sajalah.
Acid.
Why is it acid? Why is it
Can
an acid?
donate proton.
It can donate proton. Awak kena cari pasangan baru awak nampak dia buat apa. So you see HClO, it becomes ClO minus. So where is the H gone? That means it's already donated, isn't it? So it becomes the acid. Okay, so after removing the proton, it becoming your conjugate base. How about CH3NH2? Dia mestilah
Base.
Base.
base. As it's accepting a proton, become NH3 plus. So dekat sini, base after accepting a proton, it become conjugate acid. Dia adalah satu pasangan. I'm using different color for you to differentiate it better. Is it good?
Yes,
Boleh
madam.
faham?
Good.
Boleh ya?
Boleh.
Okay. So tadi siapa yang confused untuk definition, bila kita tengok example baru akan nampak sikit. Then we will look at the last sentence over here after we done the last example. So last example over here, tell me NH3, is it based on acid? NH3, is it a base or an acid?
Base.
Yes.
Base.
Base. Why? You find the partner, you see, NH3, NH4, kind of similar, isn't it? So kita linkkan sekali. Okay, so NH3, NH4 plus, what is the difference? You can see, obviously, it's accepting a proton. So bila a substance accepting proton, it is referred as a base. Okay, so NH4 plus adalah awak punya conjugate acid. So in this case, since NH3 is the base, so your reactants must be one base, one reactant. So reactant dekat sini kan, ini adalah awak punya reactant side ya. Okay, so water now is becoming your acid. So acid donate proton. So after donate the protons, it becoming OH minus, OH negative. So this one is your acid donating the proton, they become OH minus, and this becoming your conjugate base. Okay, so H2O is amphoteric. It means that it can act as the acid or base. It can either accept a proton or donate a proton. Okay, so remember amphoteric, it means it can react with both base and acid. Okay, so referring to the sentence over here, the weaker the acid, the stronger is the conjugate base. So if madam said like this, kalau madam wouldn't wanna, ni lah boleh. Okay, if let's say I say this is a weak acid, in your first examples over here, weak acid. So that means CH3COO minus is a strong conjugate base, or vice versa. Weaker base, stronger conjugate acid. Stronger acid, weaker conjugate base. Okay, or weak base were producing stronger conjugate acid. So yang ini pun kena catat juga lah ayat ni. Okay, weaker acid, stronger conjugate base. Weaker base, stronger conjugate acid, or vice versa. So any question for Bronsted-Rowley? Acid and base. Ada soalan?
No, madam.
Okay, kita test kejap Madam tak nak tunjuk definition dulu dekat sini. Akhirnya for acid, what did it say? Akhirnya acid. It has hydrogen and
Can dissociate to form hydrogen ion and H3O plus ion.
okay, so it can dissociate to form H plus, H3O plus. Bronsted-Rowley, it said it can donate H plus. So we want to look, what is the definition for Lewis? So setiap definition dia lain. Okay, so for Lewis acid, it refers to any substance that can accept a pair of electron. So nampak dah dia punya definition. Lewis acid it refer to a substance that can accept a pair of electrons. Tadi Bronsted-Rowley said it can donate proton. Sebab dia ada, Arrhenius cakap dia ada, okay? Bronsted cakap dia boleh donate. Sekarang Lewis pula argue, dia bukan setakat boleh donate tapi dia boleh accept a pair of electron. Okay, so Lewis acid accept a pair of electrons. So the species that can behave as a Lewis acid is as follow. It can be a cation, H plus, F2, Fe2 plus, Al3 plus sebab dia boleh accept electron as it is cation. Okay. And then molecule with incomplete octet central atom. This one is revising your chapter 4. BeBal, Berbal. Beryllium, boron, aluminium. So they are obeying incomplete octet. That means they have empty orbital that can accept extra pair of electron. Okay, so setiap kali kalau awak nampak BeAl, dia boleh jadi Lewis acid. Number 3, molecule that has polar multiple bond accepts carbon-carbon double bond, carbon-carbon triple bond. What is said by polar multiple bond? Madam give you example. So on number 3 over here, example you can jot down. For example, if I have carbon dioxide. I have carbon dioxide. This one is considered your polar multiple bond. Okay, or maybe sometimes you see a structure like this. Okay, I can see my carbon double bond. So it's a multiple bond. It's a polar bond. So, Madam harap awak masih ingat lagi macam mana nak tengok polar ataupun non-polar ya. Polar multiple bond delta positif, delta negatif, delta positif, delta negatif. Ini adalah polar multiple bond. Bukan molekul ini adalah polar bond. Mereka kena emphasize dekat sini polar bond. Okay. Number 4. Molecule with central atom that can expand beyond period 3 and has empty orbital. So for example, if you got sulfur SF4, maybe I have ICl3. What else we have? PCl3 and so on. Sulfur, iodine, phosphorus, they are all beyond period 3. So they will have the 3d orbitals, 4d orbitals, 5d orbitals that's empty and can accept the electron. Do you get this? Is it okay?
Yes, madam.
Boleh. So example sudah bagi dekat sini, boleh rujuk sikit lah, okay, untuk Lewis acid. Okay, on the other hand, we have Lewis base. So a Lewis base just now in the Arrhenius is say that it has OH. It dissociate to form OH negative. Itu yang Arrhenius cakap. Bronsted say it can accept proton. Okay, Bronsted-Rowley base is a substance that can accept proton. But Lewis say that a Lewis base is any substance that can donate a pair of electron. So untuk Lewis fokus dekat electron. Okay, untuk Bronsted fokus dekat H class. Siapa yang donate, siapa yang accept. Okay, so Lewis base donate a pair of electrons. So those species which can donate the pair of electron including anion. When you see a negative charge ion, OH minus, Cn minus, Cl minus, that means they have extra electron to be donated. Okay, and then we have molecule with lone pair electrons at the central atom. Bila awak nampak lone pair dekat center, it means that it can behave as the base. For example, H2O, we have the lone pair on top of oxygen. NH3, we have a lone pair on top of nitrogen. For ROH, this one is a general formula for an alcohol, yeah? We have the lone pair on oxygen, which can be donated. And lastly, molecule with non-polar multiple bond, such as alkene, alkane. So alkene CC, this one is non-polar because same atoms, right? And then alkyne is a carbon-carbon triple bond. So when you see carbon-carbon double bond, carbon-carbon triple bond, that means it has a lot of electrons. Electron density very high. It can donate electron. Therefore, Lewis base. Okay. So kita tengok dulu example. So question number 2, BF3. Oh, nampak B saja. Dia adalah acid ataupun base. Catat kat bawah lah. BF3, is it an acid or base?
Acid.
Acid.
Acid. S, it has empty orbitals on boron, or it is an obeyed incomplete octet. Awak kena catat acid ataupun base saja. Definition boleh ikut mana-mana. Arrhenius ke, Bronsted ke, untuk Lewis. But now we are trying the example for Lewis. So BF3, boron, obeying incomplete octet, therefore it's an acid. It can accept electron. NH3, it has a lone pair, therefore it is a base. It can donate a lone pair. Okay, so this example actually you have seen in chapter 4 when we do the dative bond. Dative bond kan masih ingat lagi. Tapi dekat sini kita cuma nak explain acid and base property saja. Okay, how about H plus, acid or base? Very obvious, right? A second example, H plus, acid or base?
Acid.
OH minus,
Base.
base. Cl minus, Cl minus,
Base.
Base.
base. Sebab dia anion, equal extra electron. SnCl4, tak ada pilihan kan? Dia adalah acid. But why is it acid? Why is it an
Expanded
acid?
octet.
Expanded octet. Okay, Sn is teen. It's come from period beyond period 3. So after period 3, that means it has empty d orbital. Okay. So is there any question for your sekejap ya. Ada soalan tak untuk Arrhenius, Bronsted, Lori? Ada tak ada? Okay, if no questions, Madam will stop over here first and we will continue the strength of acid base and the following calculation. So attendance. Kejap ya. Madam, share the attendance in the chat column.